We're now in Module 6, Newton's second law in angular form. And here's a key idea. Torque net is dl over dt. And I've chosen from this module problem 33. And it says, at time t equals 0, a 3 kilogram particle with velocity v, 5.0 meters per second in the I hat direction, minus 6.0 meters per second in the j hat direction, is at x 3 meters, y 8 meters. It is pulled by a 70 Newton force in the negative x direction about the origin. What are the particle's angular momentum, the torque acting on the particle, and the rate at which the angular momentum is changing? So the first is the particle angular momentum. And for that, we'll use this formula. L equals M R V perpendicular. So we'll set up a matrix. We already know it's in the Cartesian coordinates because we have I and j. So we have x is for r, it's 3. Y is 8. And we have no k. And we want the velocity. We're going to cross it with the velocity. The velocity is 5 minus 6j and 0. And we're going to multiply this matrix by the mass, which is 3.0 kilograms. Okay, when we cross out I hat, we see 8 times 0, and so we have no I hat. So we remove the j hat. We have 3 times 0 and 0 times 5, no j hat. So we only have a k hat. And that'll be k hat times 3 times the minus 6, which will give us a minus 18, minus a 5 times 8, which would be a minus 40. So this would equal a minus 40, and 18 will be a minus 58, minus 58 k hat. Now we have to multiply this to get our answer by 3. So we have angular momentum is going to equal 3.0 kilograms times a minus 58 meters per second. So it's meters square per second. K hat is going to equal 3 times 58, which is 74. That's a minus 174 kilograms meters square seconds. So that's the angular momentum. And B, the torque acting on the particle. Well, we'll do the same thing. Torque is equal to R cross F. So we set up our matrix, I hat minus J hat, K hat. R is the same with 3, 8, 0. And we got a force of 70 newtons in the negative X direction. So we'll put 70 newtons. We'll make that a minus 70. 0, and that's 0. And this is a 0.70 newtons. So when I block this out, I see I have no I hat. 8 times 0 is, go to J, 3, 0, 0, no J hat. I only have a K hat. So K hat, 3 times 0 is 0, minus a minus, which will turn that 7 into a plus, times 8, which would be 8 times 7 is 56. And that's in units of newtons. And these are meters, Newton meters. So my torque is equal to 56 Newton dot meters, K hat. So C is the rate at which the angular momentum is changing. Well, we know torque is equal to dl dt, which is also equal to R cross F. That's what we have. So that must equal 56 Newton dot meter K hat. So it is the same answer that we got for part B.